Good morning, everyone. Happy to be here today. Thanks for taking the time on a Sunday. So, what I'm going to be talking to you about today is why the best investment you can possibly make, stock market, property, anything in 2024 is actually waterproofing. Right? So this one's going to be a little bit of a different presentation. We're not going to talk about codes and standards so much. We're going to talk about the return on investment that you can potentially get when you apply correct waterproofing measures. So, a little bit about me before we start. There's some text up there, but I'll keep it brief. Why would you be listening to me on this subject? I've worked in construction waterproofing my entire professional career. I've done a lot of things wrong in that time, so you can learn from my mistakes rather than making them. As Carson introduced, I am currently the president of the Australian Waterproofing Association. We are working very hard to unite the industry and provide value to our members and the industry in advice and training around construction waterproofing. So, how are we going to go about this? Well, we're going to actually look at waterproofing from the perspective of the greatest minds in recent history for investment. And that's where I've got this quote up here from Isaac Newton around standing on the shoulders of giants. We're going to take these quotes and we're going to see how we can apply them. A little bit of an outline on what we're going to be looking at. We're going to go through a series of case studies and we're going to see how this advice from these investment professionals can apply to these case studies. So first of all, CLT, structural failure. CLT is a very new technology in the industry. I'm sure everyone's interested in how waterproofing applies to that. Next one is basement failure. Third, risk mitigation. And then finally, maintenance practices. So just recapping again, this will be the best investment opportunity you have all year. And I'm going to prove that to you. Just before we get into those real case studies, though, I just wanted to point this one out because it really highlights what I'm going to demonstrate throughout this presentation. And it's all the little things. And one of the most simple things you can have in waterproofing is something that's known as a water stop angle. Now, what this water stop angle is supposed to do is prevent exactly what you're seeing here. This is a balcony door. There's water being applied. It's raining outside. And we have water effectively coming straight underneath the door. Absolutely nothing wrong with the door frame, by the way. I was talking to a waterproofer before where he said that replacing the door, he'd been through replacing the door and all of that work, and there was actually nothing wrong with the door. It was the missing water stop angle. So another situation here, we have water coming in straight under our door frame. Now, that water stop angle probably costs around $40 supply and installed. If we need to replace a balcony and a door and everything like that, you're probably looking at, depending the size of the balcony and accessibility and how difficult everyone is to work with, because time is money as well. It's not just the waterproofing and the tiles and the door that you're replacing, it's everyone's effort and involvement. If it's a Class 2 building in New South Wales, you need to have a declared design. So you would be looking at least $35,000 in remediation. So that initial investment of $50 on a water stop angle just had a 700 times return on investment. Now, I don't think anyone would say that that's a bad investment. I'd be happy to make it. Cool. Now, as I said, we're going to be standing on the shoulders of giants here. So we've got some quotes from various figures throughout history. An investment in knowledge pays the best interest. It's from Benjamin Franklin. And then we have something quite different, but a bit more to the point, from Warren Buffett here. So Warren says, risk comes from not knowing what you are doing. Knowledge overcomes that, right? So with that, let's jump into case study number 1. CLT structure. Nice photo up there of what a CLT structure looks like for those of you that haven't seen them before. And this particular one, I won't be naming any of these projects or giving out any addresses, unfortunately, but I can tell you it was a Class 2 building and it was around 4 stories high. If you're not familiar with what CLT is, it stands for cross-laminated timber. We've got a couple of key points on the left-hand side there. So timber is at risk of fungal decay if moisture content exceeds 20%. So if water gets in, wets your structure for a period of time, fungal decay is going to set in. And in this instance, our CLT is our structure. CLT, in particular, has a small surface area to volume ratio, which means drying is even worse. Worse if you had a timber stud frame or some trusses or anything like that. CLT is much worse for how long it takes to dry out when it does get wet. So on this particular project, they went about this assessing this risk, and they said, hey, we know that this is going to be pretty bad if it gets wet, right? So they were weighing up their options, and they said, well, on one hand here, we have our liquid applied membrane. It has a 10-year warranty, and it has a lower end performance. It's still compliant with the NCC, but it's baseline, low level performance. On the right-hand side, we have a torch applied sheet membrane. It's about 8 millimeters thick, probably 8 times the thickness. It has 2 layers compared to the other one. 20-year warranty period, probably about double the design life, and accommodates a lot more factors such as movement. So in this particular instance, using that knowledge of that comparison, they invested in the torch on sheet membrane. Great move, right? Everyone's celebrating, giving themselves a pat on the back on how good of a job they did in selecting this waterproofing system. So why is this case study a problem? Well, before I explain that, this is just a demonstration of how that membrane's installed. You really shouldn't be burning the timber like that, but that's a photo regardless. They had around 3,500 square meters on this project when you looked at the roof, the balcony areas. So that's quite a substantial amount. There's a photo of the actual project on its completion. Looks quite good, right? Nice, consistent runs of sheet membrane all lapped together. So where did it fall over? Well, the problem was that they didn't continue thinking about the situation after they chose the product. So where this has fallen over is that there is no detailing, no consideration of how this product interfaces with penetrations, service ducting, balustrade posts, and our facade, most importantly. So this is pretty much the full perimeter. What we'd expect to see here is that there would be the laser pointer here. There we go. We would expect to see an upturn here. We expect to see that it's interfacing with whatever our facade design is, but there's just nothing. There's a little bit of sealant here, which is grossly deficient. So, of course, things didn't play out very well in the first 4 or 5 years of this building. What you can see here is structural rot and decay on the CLT, where all of this timber, especially right there, you can see that, all of this CLT has rotted away and deteriorated. So it was that gap in knowledge between thinking that they only needed to choose the correct product, and they stopped thinking about how do we install this? What's the design? What's the sequencing during construction? Just another quick photo here showing that deterioration from another angle. Okay, so that's where it fell over. It's quite simple. Now, what we're going to do is compare the costs over the first 10 years. Why are we choosing 10 years? 10 years is the duty of care period. Now we're under the DBP Act. So our left-hand columns here are what we'd call the defective waterproofing. And then we do a comparison of what the performing waterproofing would have looked like. So here you can see we had an initial cost of $420,000. There was a little bit of cost for defects at the end of the job. And then what happened in year 2 is they started to see that all their finishes were growing mold and needing to be repainted. They paid $20,000 to take care of that at the time. Then by year 4, it was happening more and more. It was getting even more widespread. So by the time year 5 and then year 6 hit, they realized this is now a structural problem. We need to fully remediate everything. Full removal, that includes declared designs, it includes access, it includes rehousing all of the tenants at that time. So they ended up taking a bill of just over $1.5 million for that. Then we go into year 8. They're back on a very minimal maintenance plan because that was effective. And by year 10, we've hit just over 2 million in costs. So let's compare that to what it should have been. The difference here between 420 and 540, an additional $120,000 would have allowed for a proper design for all our interfaces and junctions. It would have allowed for the extra cost and time for the waterproofing contractor to do it correctly. And then we make a little bit of allowance here for minor defects. And then this is all we've got, $2,500 every 2 years for a bit of inspection by the warranting contractor and some minor repairs that might have occurred. So by year 10, we're hitting $565,000. So big difference there you can see. Let's just point it out. An additional investment at the time of construction of $120,000 would have saved a total of $1.5 million over 10 years. So that's a 12.5 times return on the investment. See, I'm getting there. I'm going to win you guys over. You're all going to be investing in waterproofing by the end of this one. Cool. Now we're going to move into case study number 2, which in this case is a basement design. So we're going from rooftops, now we're going down into the basement of the building. And before we do that, this is probably my favorite quote, actually. This is by Charlie Munger, the late partner, longtime business partner of Warren Buffett. Now, what he said was, it's remarkable how much long-term advantage can be achieved by trying to be consistently not stupid instead of trying to be very intelligent. Now, I'm just going to have a drink here. Okay, so what does that mean? We're going to demonstrate that with this case study. So in this particular basement, this structure is just indicative. It wasn't a house, it was a large Class 2 building. They had initially a design for a continuous, impermeable, solid barrier that runs the full extent of the basement, just one big plastic liner. Has been used many times, has a high level of confidence. Well, that's how it started out. And then we had our design team, our engineering team, site team, whoever it was, started to get clever with the design. And they proposed a couple of things. They said, we can save time and cost if we delete waterproofing to the wall, the vertical element. What we're going to do instead is engage our shoring wall contractor to provide a watertight structure. And that might be done with water stops or concrete additives or something like that for this diaphragm wall. Now, it is technically possible to do this. It all works on paper. Okay, that has a little bit of merit. The next one is we're going to use a swellable bentonite sheet below the raft slab, and then we're just going to terminate it into the diaphragm wall. And the waterproofing contractor is going to take care of that. Okay, sounds good. So that design was approved, it was developed, and it was constructed. And this is what that looks like. Vertical element here, that was done by the shoring wall contractor to be watertight. And then we had the raft slab here, and our green line is our waterproofing membrane below it. Both reasonable elements in their own right. You can see the blue we've got down here. That's our water that we're trying to keep out of the basement. So what happened? Well, when this raft slab cured, it was a relatively large size. So there was a degree of movement where that slab pulled back away from the wall. It might have only been 5 millimeters or 10 millimeters at the absolute most, but it was enough to create a pathway up here. And this type of waterproofing membrane, while it was intended to connect into this shoring wall here, the product selection isn't able to do that. Those products work via swelling in a confined space. We no longer had a confined space here. So our water rose up under hydrostatic pressure, several levels below the ground here, rose up out of hydrostatic pressure and came into our basement. So here's some photos of what that looks like. And I hope you can see this. Our shoring wall here, our concrete slab, and then we had an internal blockwork wall here. You can see that this entire area has about 40 or 50 millimeters of water constantly coming up from below and flooding out. See the block wall on the left-hand side here as we jump to the next photo. That's the block wall. Water is running straight under it out into our car park and accessible space. Got another one. Water's running even further as there's essentially a constant source of water for the groundwater here. This is meant to be a lift lobby. It was still in construction at the time. Water completely running through this area. And so what we're seeing here is a weakness between the vertical element and the horizontal element, right? But not only that, there were also deficiencies in the way the raft slab was poured. There were cracks, and the membrane wasn't suitable to stop that water coming up, so the product selection wasn't great. And also, this is our shoring wall. You can see there's a lot of injection work being done here already to try and stop that water coming in. So water was coming in through everywhere, but the main point was the wall to floor junction there, right? So let's take this back to what Charlie Munger said and try and analyze here what the difference is between trying not to be stupid and trying to be intelligent. And someone that's trying not to be stupid would, because there's nothing that makes us look worse than having something that's failed, right? A poor outcome. So someone that really wants to just look like they've done a good job chooses tried and tested methods. They understand that you need a solid level of evidence to have design confidence. You engage relevant experts to fill in any of those blanks in your knowledge, and you seek scrutiny to ensure that risks are mitigated. Compare that to someone that's trying to be too clever or too intelligent. They would take risks on experimental concepts, things that sound like they're good on paper but haven't really been shown to be tested. They don't look for all of the evidence. They find a little bit, yes, the wall's good, yes, the slab's good. No one looked at whether the junction was good. And finally, confirmation bias. For those of you that aren't familiar with what that is, I see this in the construction industry all the time. Everyone wants to be the person that came up with the idea that was the best one and got used. So rather than questioning, okay, I've got this idea, is it the best one? They start to seek information and seek affirmation that it is the best. So let's do our cost breakdown here as we've done before. I'll try and move through this one quickly. So in this one, our costs came in pretty quickly. So the initial costs to do what was done was $450,000. You saw the amount of water that was coming into this basement, right? So before they even had occupational completion, they had to spend $810,000 in resin injection and rectification to stop that water. So before the project was even finished, they'd already doubled what they would have spent if they followed the original design. Not only that, resin injection isn't perfect. They had to spend $30,000 a year for every 2 years in the period after that. So by the time we hit year 10, we're almost at $1.4 million to keep water out of this basement. Comparing to if they had followed the original design, which was tried and tested and understood to be working, we have very, very limited life cycle maintenance here. You should never have to do any work for your basement because it's so difficult and costly to have that happen. So we ended up at $825. How do those compare? Well, we would have spent an extra $170,000 to stick with the original design, and that would have been a saving of $930,000 over 10 years. So that's 5.5 times return on investment. Not as good as the other ones, but still pretty great. I wouldn't be unhappy with that. So, case study 3. Now, this one's a little bit different. This is going to be talking about how we assess and understand risk, because I'm sure you would agree that there are different scenarios that have different degrees of risk, right? This one that you can see here on our cover slide is a reflecting pool or maybe a swimming pool over the top of habitable space. There's landscaped area. Down on that bottom lower area there is all habitable internal space. So before we talk about how this case study played out, here's our quotes. So this one's from Minish Pabrai. Minimizing downside risk while maximizing the upside is a powerful concept. And George Soros says something very similar, where he says, it's not about whether you're right or wrong that's important. It's how much money you make and whether you're right. How much money you make when you're right and how much you lose when you are wrong. So minimizing and maximizing. And how do we go about doing that? Well, we use a risk matrix like this. This is something you might have seen from safety. It's a way of implementing safety measures, but it's also equally important here. So you can see our different axes here. On the y-axis, we have probability. How likely is it to occur? And on the x-axis here, we have impact. How bad is it going to be if it does occur? So to explain this, we're going to look at 2 different scenarios. Scenario number 1 is a covered balcony. Everyone's seen class 2 apartment buildings. balcony over balcony. That's what I'm talking about here. So it's covered by the structure above, so you almost never get direct rain onto it. It does require to be waterproofed. You have a tile and pedestal finish. So if you think that there's anything that's wrong, you lift up a tile, you check it, maybe you repair it, nice and easy. And there's also low consequence of failure because it's external space above external space, right? On the other end of the spectrum, we have scenario 2 is our exposed green roof. Now, this one's open to the sky. Every time it gets rains, the area is going to get wet and it's going to hold water. It's not easily accessible for inspection and maintenance because of all the landscaping that you would have to remove. That's not an easy thing to do. And it also has a high consequence if it was to fail, because we have a very high-end fit-out in our habitable space below. So then, how do we do this, right? We've identified the risk. What do we do? Well, we put in mitigation measures to offset that risk. We are minimizing the downside by putting in a more expensive system. So this is just a really quick comparison. On the left-hand side, we have a cheaper option, still compliant, but cheaper, has less performance. And then on the right-hand side, we have a higher performing. It might cost about 3 times as much, but the performance is about 3 times as much. So before I get into the next slide, the logic here is that you don't need to spend more of your budget on a project. On any given project, you're going to have a certain amount of budget for waterproofing, right? What would be a mistake, which is I'm about to show you, is to just do the same thing everywhere. What you want to do is identify where the lower risk areas are and put a lower performance system in there. That's no problem, right? And then you want to take that excess budget and you want to invest in putting a higher performance waterproofing system in our high risk scenarios. So if we now look at this particular project, which did fail, and we'll have a look at why, the interesting thing you'll find here is that these numbers at the start are almost exactly the same. Because what I'm talking about isn't spending more money over your budget. I'm talking about redistributing your budget so you spend it where it's higher risk and higher consequence. So in this scenario here, we spent our waterproofing, same quality of waterproofing across the entire project. There was some smaller issues in the start, and then by year 4, our higher exposure areas, the waterproofing wasn't able to withstand it successfully, and it failed, and it needed significant repairs. After those repairs were done, and they put a high performance system in there, it was very cheap for the following years. So we ended up spending $975,000. Where if we had have done the performing waterproofing option, the $10,000 just accounts for doing that risk assessment, taking that time, looking at the different products and applying it. So almost exactly the same. And then we see that our maintenance and everything's working the way it should. Everything's quite a lot cheaper. And we have a cost of $270,000 just for doing that little bit of thinking about what's our risk and how do we mitigate it where we need to. So recap, initial investment of $10,000 saved us $725,000 over 10 years, which is 72.5% return or multiplier return on investment, which I think that one's awesome. We spent nothing up front other than a bit of extra thinking time, and we made a $72,000 return on that bit of advice on how we should distribute our waterproofing budget. I think that's very powerful. So, on to case study number 4. This is our last case study. This is maintenance. What you can see here, this is a rooftop car park. And the thing that should stand out to you is this large chunk of waterproofing membrane right here, which is just peeled off the rooftop. Obviously not what we want it to be doing. So before I explain what's gone on here, let's have a look at the great Warren Buffett. And his advice is, if you aren't willing to hold a stock for 10 years, do not even think about owning it for 10 minutes, which is quite coincidental that our duty of care period is also 10 years. So thanks, Warren. Now, to explain what happened in this scenario, let's have a look at vehicle trafficable waterproofing, because I suspect not a lot of you might be familiar with that. It is something reserved for shopping center car parks and higher risk, higher exposure areas like that. So you can see in this diagram here, we've got the 5 different layers of buildup. And I think I've got a video here on what the installation of this system would look like. This is effectively a time lapse showing preparation and priming layers and all of the different layers that you build up in order to get a system that will actually perform. What they're doing there is actually throwing a sand aggregate in it, which gives it a more rigidity and durability. And that's pretty much it. So that's a time-lapse, 5-layer system, very hard wearing. And that was the system that was installed on this rooftop here. And this is what it looks like about 6 or 7 years later. Now, it might be difficult to see, but if you can see any difference in color here, that's because the waterproofing has been worn down. All those layers have a slightly different color. So that's why this roof looks very spotted here, because depending on how much traffic each specific location has, then it's going to be worn down to that layer. So having a closer look at what's gone wrong with this waterproof, this rooftop, structural slab deflection created low points where water would pond after it's rained. These are areas where posts were fixed and removed, and they were rectified very poorly with a little bit of sealant around the cutout and the infill. Here we can see there's just large chunks of the waterproofing missing. It's still intact but worn here. And then this is effectively concrete and primer here. So not great outcomes. And this is the consequence. So in this particular case study, this wasn't someone's lounge room or bedroom, which would be very inconvenient if it got wet, right? What was actually below this space, I don't know if you can see, but there's a movie poster in the background there. This was the projector room for a movie cinema. So water coming in here has damaged all of these ceiling panels. You can see that. The ones that are missing here were so damaged that they collapsed. There was electrical work everywhere that was being damaged. And if you didn't know, cinema projectors cost at least $100,000 each. And they were regularly getting dripped and water damaged on these projectors because of the lack of maintenance and the consequences that came of it. So let's have a look at our cost comparison here. For this specific area, the initial cost was $250,000. They did practically zero maintenance. That $500 is for the plumber to come up there and put a little bit of sealant around things that were supposedly the source. So by the time they hit year 8 and legal action had commenced by the occupant of the tenancy, they were forced to pay $480,000 to rectify it, full removal of the system, design specifications, full system installed, which took them to $730,000 at the 10-year point. Compare that to what would have been a performing waterproofing option, exact same price at the start. The investment came here in the years following in the form of maintenance. So at year 2, there was only minor maintenance and inspection, but year 4, there was something a bit more substantial. They had to go in, they had to recoat the top layers. The layers that had been worn off, they needed to build those back up again. That's why there is so many layers, to allow for wear, and you can replace those. Then we do the same thing in year 8. And then by year 10, we've spent a total of $310,000. Comparison, the maintenance investment of $16,000 to achieve the quality waterproofing system saved a total of would have saved a total of $480,000 over 10 years. So that's an 8 times investment, return on that investment. Cool. Now, we were talking about 10 years. We've been talking about 10 years the whole time. Warren Buffett said, if you don't intend to hold something for 10 years, don't hold it for 10 minutes. Now, this is particularly relevant because of duty of care. Now, what this QR code is here is a link to the website which shows you all of the stop work orders, prohibition orders, and building work rectification orders that Fair Trading and Building Commissioner's Office have issued. You can look at them right now. And the building work rectification orders, those are the ones that are particularly relevant because these are projects that have been completed. They're in the 10-year duty of care period, and the occupants have called out the building commissioner's office and they found defects, and now they've been issued a work order to rectify them. So there's at least 60 on there. And they're updated very regularly as new ones are issued. Now, I know I said I wouldn't talk about projects, but when I checked, need to get that QR code. Mate, I'll send you the slides out later. Come and see me. Okay, so I wouldn't normally talk about projects, but it just so happened that when I looked at the website for the purpose of developing this presentation, I found this project, which is probably a little bit too small for you to read, but it was a project that we provided design advice on in the very early stages. We gave them design advice for their lift pit, and that was great. Everything went well. Lift pit didn't leak. We didn't hear from them. Works progressed, and they got audited by the building commissioner's office, and the reason they received this stop work order is for insufficient design detail for their internal waterproofing, which had resulted in issues. So they started out right with their lift pit. They'd done a great job. And then things just, whether it was the pressure of the project, things fell off. And they ended up copying this stop work order, which you can all imagine the costs on your construction loans for every day that's delayed. So I want to talk just a little bit. We've done the case studies on how to choose your consultants, because really this sort of advice on how to mitigate these issues is the plan, right? But what I want to point out, and we'll use this quote here, if stock market experts were so expert, they'd be buying stock and not selling advice. Sort of makes sense, right? And here's another one from our building commissioner, David Chandler. The price you pay for the advice you want to hear is often very different to the price that you end up paying. So what do I mean by this? Well, I'm going to give some pointers on what I think of having done this for a little while now, is things that you should consider when you're engaging your consultants that are going to give this advice on how to mitigate these risks like we've been talking about. So the first one, relevant qualifications. Makes sense, right? Nothing too crazy there. Recognition or accreditation with relevant industry bodies. There's a lot of industry bodies for different practitioners, Engineers Australia, Architects Institute, Certifiers Association, for example. At least 5 to 10 years experience with intended project types. So you want them to be familiar with your project types. There's a very big difference between waterproofing a class 1 building and a class 2, 3, 9, anything of that sort. Just as an example. Deep level of expertise on materials, methods, best practice guides for the intended building elements. One thing I've seen a little bit differently is, say, engineers that have historically done, let's say, fire engineering are now saying, well, hey, I can give you a bit of advice on waterproofing as well. So something to be aware of. There's advice and then there's advice. Thorough understanding of relevant standards and regulations. We have to comply. We know that now. It's what the building commissioner enforces. So not only knowing what's good waterproofing, but what's compliant waterproofing. They should be the same thing, but there are differences. It's important to know. Strong communication and demonstration of ability to problem solve. You could have the best knowledge base in the world, but if you don't know how to communicate it to the team and how to use it to solve a problem, it's useless, completely useless. The very last one is a history of integrity, ethical conduct. That just means trustworthiness, right? And I'll do a bit of a shout out here for iCert rating. That's what iCert is pushing. It's demonstration of trustworthiness. Because if I was asking any of you now, you're going to engage a consultant. Do you want one that is going to work in your interest or someone that's going to work in their own interest, which means getting paid, moving on, and you're left holding the bag for it? So I think we've got a bit of a quote here from Warren.
We look for 3 things when we hire people. We look for intelligence, we look for initiative or energy, and we look for integrity. And if they don't have the latter, the first 2 will kill you. Because if you're going to get somebody without integrity, you want them lazy and dumb. I mean, you don't want them smart and energetic. So
someone that has no integrity, you want them dumb and slow, because then at least they're not going to be able to do any damage to you. So I thought that was a pretty interesting one. And as a final warning sign, I hear this pretty often. It's a flag, right? It's a note for concern. I know someone that will sign that off for you. The amount of times I've seen, and I understand the pressures of projects that you just need to get it done and get OC so you can move on, it does come back. You all know it's going to come back if it's actually a performance issue. So just be mindful of it, because that person that's willing to sign it off probably doesn't have any integrity, so they're not going to be there for you when you need it. Okay, so with all of that understanding, what do we do now? So I'm going to show you, I just need a quick drink. Oh, but before I do, this is our last quote for the day. The best time to plant a tree is 20 years ago. Who knows what the second best time to plant a tree is? Second best time to plant a tree is right now. Chinese proverb. I wasn't aware of that until I was researching this, but great advice. So what it means is it's not too late. Start right now. Whether you have projects or developments that are currently in progress, it's never too late. Embrace these concepts, and these are just some of them, but I think they're valuable in order to improve your outcome. So the first one's going to be knowledge. Nothing against Bunnings, but probably the DIY guy isn't the one to follow, depending on what type of project you're on. So I've got a lot of other sources of knowledge and professional development here. That's the first one. Second one I'll explain after you watch this video clip, because it makes the point very well. For those that can't see, we've got the 3 panes here. The guy's drawing Spider-Man. Left-hand one, he's got 10 minutes to draw it. Middle, he's got 1 minute. Right-hand side, he's got 10 seconds. Okay, so we all know that time is money. So what's the point I'm trying to make here? You need to have the right budget in place. And we've also got our comparison here between our nice horse balustrades. I enjoyed that one. So first of all is when you're pricing a project, right? Research the market price of compliant waterproofing. I know that's easier said than done sometimes, but the amount of times that projects have gone wrong purely for the reason that it wasn't budgeted, so we just do whatever our budget allows, and then someone else pays the expense later. Next one is assess risk. So this isn't even talking about having a bigger budget. It's just talking about understanding where your risks are and channeling your budget into that direction. And then finally, redistribute budget from lower ROI cost centers. Maybe you don't have as nicer bedroom cupboard doors because you need to put a little bit of money into waterproofing so that you're not paying that massive penalty fee later. Point number 3 is design. So the whole Design Building Practitioners Act is really a simple concept, right? It's just do your design first, think about it, make sure it's good, and then build it. That's hugely different to what we were doing as an industry previously. And that goes back to the old carpenter's adage of measure twice, cut once. Follow the Design Practitioner's Handbook. It's got a lot of advice on what good design looks like. And then design management to ensure coordination between design stakeholders. This is actually still a pretty big one. We'll have a lot of really good design stakeholders on the project, but if they're not working together and having someone force them to communicate on the important points, things fall over quite badly. And then finally, recapping, choose your consultants wisely. Point number 4, quality control. So you see we've got paper records here crossed out. You can still use them. There's no legal reason why you can't. But I sort of feel like we're past that as an industry. I feel like it would be harder for me now to do paper records than use some of the really handy, inexpensive digital software out there that allows us to have digital records. We can record date and time and what was happening and take a photo, and it's all right there. Next one is appropriate quality testing methods. So there is quality measures for different situations. Make sure you're putting the right things in. And then independent inspections. Anyone that says they inspect their own work is overselling themselves. Everyone that looks at their own work is going to give themselves a good mark, right? That's where the value of peer reviewing is. Someone looks at it from a different perspective and they see the faults and they help you get it right. And then finally, choose consultants wisely again. Okay, so with that, thank you, everyone. I hope I've at least somewhat convinced you in the value of what investing in good waterproofing outcomes can achieve for you. And with that, I would like to invite you to a future event that I'm also going to be speaking at with Will and also Michael McQueen. This, we're going to also be looking at the future in a way of investing as well, but it's investing in opportunities. There's a lot of people here today that are waiting for, well, what's the next change? I can tell you that the public comment draft for the NCC 2025 comes out in about 3 weeks, and that's going to change the industry again. All the ways that you thought you were building with your structure, you're going to have to rethink it. Tiled floor finishes is going to be totally different. So this event is all about being able to grab those future opportunities, make an investment in the change that's about to occur, networking with the people that are also interested in that so that you can leverage those possibilities together. So by all means, grab a scan of that QR code because it gives you 30% off, and I don't think that'll ever be offered again. And then finally, I just want to say thank you. Thank you for taking the time today. I hope you enjoyed this.